Hello everyone, and welcome to another DIADEM Elite tutorial. Today we will be covering how to use the predictions window to effectively estimate chemical properties. First, we will go over a brief introduction to the structure of the predictions window. Next, we will go over some guidelines for making effective predictions. To open the predictions window, we can simply click Predictions in the main window of DIADEM Elite, and the window will open. And here we are. Click on Predict. Now let's briefly walk through the structure of the predictions window. At the top of the window, we can see a space to select the kind of property we want to predict, constant or teed up, followed by a drop-down menu listing the different properties in each category. After the property drop-down menu, there is a method drop-down menu that we can use to select which method we want to use to predict the chosen property. If we select teed up, we can see several text boxes for inputting temperature parameters, like the number of points we want, the temperature if the number of points is just 1, or if, for example, the number of points is 5, we can see the upper and lower temperature bounds. We can also adjust the units of our temperature here. If the prediction method we are using is a group contribution method, we can use the View Edit Groups button to verify that the correct groups are there and to make any adjustments we would like to make. The Predict Property button runs the prediction when we have configured everything to our liking. Next, on the sidebar, we can see several options. At the top, we can choose whether we want to search for any number of compounds in a database, right here, or to use the SMILES formula to make a prediction for a compound outside of a database. If you've never heard of SMILES, it stands for Simplified Molecular Input Line Entry System. For more information, you can view the documentation at the link in the video description. The options below these radio buttons depend on which button we select. If we are making predictions about a database compound, we will see a Select Compounds button, which we can use to search for the compounds we want to make a prediction about. Below the Predict button is the Evaluate button, which we use at Dipper to evaluate how a prediction method performs on compounds in the database. This feature is complex enough that it merits its own video, but for now, just know that it's there and that it's helpful for checking the quality of a prediction method. Last is the Help button, which can be used to answer questions about the predictions window from inside DIADEM Elite. If we are making predictions based on a SMILES formula, we will use the Pred by SMILES button instead. Now we will only see the Help button, as well as a field we can use to input our SMILES formula. We can also load a list of SMILES from a text or CSV file using the Load from File button.
Let's now walk through the rest of the predictions window by making a simple prediction. For this demonstration, let's try to predict the vapor pressure of propane at 273 Kelvin using the Rydell method, not the BYU Rydell method, though we'll use that one in just a moment. To begin, we will select Pred by Compound and select Compounds. Now we can simply search for propane in the database. We'll select propane and click Predictions to return to the main interface for predictions. From there, we will select Teed Up, then choose Vapor Pressure as our property and Rydell as our method. Now, as you can see, there is some additional information here in the Parameter Details box. This box displays a bit of information about the parameters used by the current prediction method. If you would like more information about a parameter, you can often click on it, and a description of that parameter will appear. For instance, the TBR parameter of the Rydell method is calculated with the formula NBP over TC, as shown here. Each parameter also has a type, such as a property, like TC, or internal, if it's a value calculated by DIADEM, and a source, such as calculated, predicted, or user. If a parameter source is listed as user, then the value of that parameter must be entered by the user in the value column. The user can also provide values of their choice for any other parameter as desired by entering a number into the value column. If more information on the prediction method and its parameters is desired, the user can usually find the paper describing the prediction method from the reference details box. Now let's run this prediction. We want the vapor pressure of propane at 273 Kelvin, so let's set this temperature. We will check groups with the View Edit Groups button for the purposes of this tutorial. This method uses no groups, so we're good to go. Let's close out of this pop-up and select Predict Property. After a brief pause, the results of the prediction appear in the prediction results box. This displays the predicted value of the vapor pressure, along with the units, the temperature of the prediction, and a comparison with the database value for the property, if a database value is available. We can click on any of these fields to see additional details about the prediction, such as the calculated value of each parameter and any groups the chosen method may have used. There are several other actions we can do with our prediction result. If we want to quickly compare between the results of different prediction methods or the results of different molecules, we can use the graph results window to get a visual representation of the prediction outcomes, shown here. We can choose which results to include in our graph by checking the result in the graph column of the results table, right here. Additionally, if we want to export our results, we can click any of the export buttons to store our results in the corresponding file format. Lastly, we can select all results using the Select All button, and we can clear the results table using the Clear button. Individual results can be removed using their red X to the far left side of the table. What if we wanted to run this prediction on propane, but didn't have information on it in the database? Let's now predict the results for propane using Predict by Smiles, leaving all of the previous settings the same. We will click on the Pred by Smiles button, and then enter propane Smiles formula, CCC. Now we will click on Add Smiles Compound, then Predict Property. Now the results for the prediction will appear here. Notice that the results are slightly different than what was calculated when we used the database information on propane. This is because the Predict by Smiles algorithm used other prediction methods to estimate the physical properties used by the Rydell method. In a practical situation, you would generally want to come up with good predictions for these properties using the procedures we will outline soon, then enter their value in the value column after switching the source to user. Additionally, if you want to predict a parameter like NBP, but you want to use a method other than the default prediction method used by DIADEM, you can enter the name of the prediction method into the value column of that parameter. For this demonstration, we'll use the Miller method instead of the default NewLoud method. As you can see, when I type Miller into the value column for this parameter and run the prediction, I get a different value than I did previously. These methods of inputting prediction parameter values also work for Pred by compound. Let's say now that we want to use the BYU Rydell method on this Smiles formula instead of the Rydell method. To do so, we can simply select the method using the Select a Method dropdown. Now when we try to click Predict Property, we can see the following error. Parameter E must be specified by the user, but it is not currently specified. This means that this method requires user input for the E parameter. For the purposes of this demonstration, we will enter a value of 3 for E. Now we can predict the VP value of propane at 273 Kelvin with this method.
A fully detailed overview of the process of making good predictions is beyond the scope of this video. However, the following 4 guidelines will help you to know when to use which methods for different classes of compounds. These simple principles will help you to make better use of DIADEM Elite's prediction tools. Guideline number 1, use the Policies and Procedures Manual. The first thing you should do whenever you are trying to predict a thermal physical property using the predictions window is to check the Policies and Procedures Manual. The Policies and Procedures Manual contains DIPR's guidelines on which methods are preferred for each property and is the best starting point for predictions. If you are a sponsor, a copy of the Policies and Procedures Manual can be found in DIADEM's documentation, which is, by default, located on the C drive under Program Files, DIPR 801, DIADEM Elite Documentation. If you install DIADEM Elite somewhere other than this default location, look there for the file. If you performed a custom installation of DIADEM Elite and chose not to install the documentation,
you can still access it on the AICHE box site under All Files, DIPR, Common Project 801 Database, and DIADEM, DIPR 801 Policies and Procedures Manual.
Open the Policies and Procedures Manual, then find the section on the desired property under Property Summaries in the Policies and Procedures Manual. This section provides a brief synopsis of each relevant property. The section relevant to this analysis is Calculation Methods. This will usually contain an overview of which prediction method best suits this property, and the circumstances that those methods work best under. This is the best place to start any prediction. If a prediction method requires user input, like the BYU Rydell method did, you can find the original paper describing the prediction method through the Policies and Procedures Manual so that you know how to input reasonable values. We can also find the quality codes for each prediction method in the Quality Codes for Prediction Methods table found at the start of the Property Summary section. These codes are a rough estimate of the uncertainty of each prediction method, though predictions can show more or less error than these estimates would suggest, depending on the compound they are being used on. Guideline 2. Use more than one prediction method. If you only use one prediction method, it can be difficult to tell whether your prediction is an outlier. Using more than one prediction method gives you a better sense of whether your predictions are reasonable. For instance, if multiple prediction methods cluster around a specific average value, that value is likely to be more reasonable. If the values predicted by various methods are scattered over a wide range, you may need to try another tactic to get a reasonable value. The graphing tool can help you to make sense of this. As a side note, while graphing in the predictions window doesn't currently work with Smile's predictions, we intend to fix this issue eventually. For now, you can get around this by creating a user database for your compound and then using a pred by compound. Once we have finished our updates to the Add Edit window, we will release a video showing how to use the Add Edit window to create user databases. Guideline 3. Compare with known values from similar compounds. If you are aware of trends in the family your compound belongs to, and know information about other compounds in that family, then you can use those trends to gauge the reasonability of predicted values. Sometimes family trends have outliers and deviations, so this isn't a perfect method of determining if a predicted value is reasonable, but it works quite well in most cases. Guideline 4. Always check your groups. Though every effort is made to ensure that DIADEM's group contribution methods are accurate to the original publications, sometimes the group parser still makes errors. Additionally, depending on the specificity of the method, there could be some ambiguity in which groups should apply to which compounds. Some group contribution methods may also not contain enough functional groups to fully describe the compound you are trying to predict properties of. If this is the case, you may need to substitute in a similar group or use a different method entirely. As such, when using a group contribution method, it is good practice to check that the groups assigned by DIADEM fully and accurately represent the molecule. If you notice any errors in the group parsing, please report it on our Zendesk at supportdipper@byu.edu. Our programming team is currently working to implement a check for complete representation of a compound. We hope that the information in this video will help you to make effective predictions and enable you to make good process design choices. As always, if you have any questions, suggestions, or bugs to report as you're using the predictions window or anything else in DIADEM Elite, please feel free to reach out to us on Zendesk at supportdipper@byu.edu. Thank you so much.